this is the physical science lesson video for section 5.3. This video is going to be super short because I literally have 3 slides on this part. As always, if you want my videos in one spot, just subscribe to my channel and you'll have them for the whole year. Alright, so the reason this lesson is going to be so short is the main way that I teach this section is through y'all coloring the periodic table. So you'll see a big slide and I'll kind of go through it with you, but really you just got to know the periodic table. So a valence electron is an electron that is in the highest occupied energy level of an atom. These electrons play a key role in chemical reactions. So like if you look right here at boron, the valence electrons are in the 2nd energy level. If you look here at silicon, our valence electrons are in the 3rd energy level and we have 4. Here in boron we have 3. And if you look at antimony, we're on 1, 2, 3, 4, 5. We're on the 5th energy level and we have 1, 2, 3, 4, 5. So the valence electrons are just the furthest electrons in the highest energy level of that atom. Elements in the same group have similar properties because they have the same number of valence electrons. So if you look, this is a periodic table where instead of putting the elements, we put how many valence electrons they have. And so if you look, in group 1, they all have 1 valence electron. In group 2, they have 2. You skip the transition metals. You'll find that we skip over the transition metals a lot. And that's because really their transition metals just act weird sometimes, and we'll start talking a little bit about electrons jumping around and things like that, but mainly you'll cover more of that when you go to chemistry. So then when you get to group 13, they have 3, group 14 has 4, group 15 has 5, 16 has 6, 17 has 7, 18 has 8, except helium only has 2. Helium has an atomic number of 2, so it can't possibly have 8 valence electrons when it only has 2 electrons. So that's why they have similar properties. That's why in chemical reactions they react similarly, is those valence electrons. So really if you look at the group number, because it's 13 through 18, if you take the 1 off, so like group 13, take away the 1, it has 3 valence electrons, like that. So this is the periodic table that I always have my students color, and so it just shows the different groups on the periodic table. So here we have the alkali metals. Here in group 2 we have the alkaline earth metals. Here in the middle we have the transition metals. Here, right here, this kind of light green color, these are the elements that are up under the stair step. These are just other metals, because we know the metals reach up into the stair step. If you look, here is our stair step line, and you can see those metalloids that surround the stair step line. Here we just have some nonmetals. These are also nonmetals, but they have specific names. So this group is called halogens. This group is called noble gases. Don't forget that also hydrogen is a nonmetal. And then across the bottom we have our lanthanides and our actinides. Alright, so I always have my students color a periodic table for this, and so just make sure you know the different parts of the periodic table. So instead of us going through it in a long, boring lesson, we just color. So this is the main beef of the section. So next is section assessment. Explain why elements in a group have similar properties. Well, they have the same number of valence electrons. Remember, valence electrons are what plays a key role in reactions, and so valence electrons are the same in a group. So elements in the same group have similar properties because they have the same number of valence electrons. So hopefully now you know a little bit more about valence electrons and the different groups on the periodic table.